I don't know if it's morning, evening, or afternoon. Yeah, my name is Kapembwa Simulinga, and I'm doing audio and music technology at Evelyn Horn College. Yeah, so today I'm going to be walking you through how what we have in our studio so that when you come, you won't have any challenges to tackle what you're going to be recording. And with me here, first of all, you can see around that it's a very equipped studio with a lot of equipment at our disposal, of course, to use. And first of all, I'm going to start with what powers this. Of course, it's electricity. Where it's coming from, we have a socket there, right there. I'm going to show you. Yeah, we have a socket there, and from the socket, the power comes through this power extension. And as we can see, this for now is not important, or because it's not in our explanation at all. So this adapter or power extension cable, we have this connected, and from here we can go to here and see what we have. Okay, here we have the our power supply or our power surge distributor. This power surge distributor helps us to connect all the equipments in this room to one source, allowing us to protect us from having noise from connecting equipment from different sources. So this power surge distributor helps us to protect us from having buzz or harm which might come due to having connected our equipment to a lot of circuits in our system. So I'm going to start with the computer. A computer in our system helps us to interact with audio and sound. So audio, the difference there is in audio, we are not going to be listening actually. We are going to be manipulating the sound. So in sound, it's what we hear. What I'm producing right now is sound. So that's where a microphone comes in. It's changed into analog, and then we have other equipment here. We have the interface here. I'll explain more on what happens. I'm just creating a picture. We have the interface here, which helps us to then create our digital audio, which is manipulated here on the computer. So the computer links us between audio and sound, whereby if I power on my computer, I'm going to go in my DAW or digital audio workstation. For now, let me open Reaper. Yeah, we have Reaper as our digital audio workstation where we can manipulate the sound through audio. So the computer gives us privileges to set the sample rate, the bit depth, and the like. The sample rate is the number of times we are sampling the sound. According to other theories like the Nyquist theory, which states that sound is supposed to be sampled twice its highest frequency. So in our case, we can change and do everything there in the computer. And that is cardinal, especially if we are using the sound card of this computer. But in our Edge, we use the sound card as our interface, which helps us. So we are supposed to change the sample rate and the bit depth, which is the number of available samples which can be sampled. So if we set the bit depth and the sample rate in the computer here, it's supposed to sync with our interface. So, okay, in our digital audio extension, we can go to options, and in our options, when we go to preferences, we can find what I was talking about. Here we can do a lot of things with our computer. Request sample rate here, the one we use in this studio is 48 because it's considered as it gives us the privilege to sample more samples of sound, thereby giving us a professional sound which we need, high quality sound. And putting it at 148, we can also We can set what we want, our MIDI devices, audio devices, a lot of things we can do here. In other words, a computer is a processing device which can accept data, process it, store it, and output our information, of course, in another definition. So in our case, the input, which is the data which we need, is the audio. The computer helps us to use it, gives us an interface to interact with audio. So getting from the computer, we can go to the audio interface. So in our case, our audio interface is an Apollo X8P. It has an 8-put channel, and of course, we can see down here, there is also an audio interface, and this one is an Audient, and it is linked to this Apollo X8P to facilitate more channels. It also has 8 input channels. And what is an audio interface in the first place? An audio interface is an equipment which helps to facilitate a link between the computer and other equipment in the studio. So this audio interface in our case has a lot of parameters, and I'm going to look at the most important parameters for now. And I'm going to start with what we have here labeled as preamp. And a preamp is an equipment which is used to increase the level of a signal from a microphone or an instrument level into a line level, which can be recorded and manipulated in our digital audio workstation. So this preamp boosts the level of that signal from, of course, microphone or instrument to line level. And on this preamp, we have this gain knob. The gain knob is used to determine the amount of signal which is allowed to be recorded. This gain knob is used to gain stage. Of course, gain staging happens before you record. So before recording, you have to gain stage your all channels, of course, as I said, or 8 channels. And this gain knob, again, it can be used to select channels. As you can see here, as I'm pressing it, it is moving. So to each channel I go on, using this, manipulating this gain knob, we can change the amount of signal which is allowed to be recorded. And of course, ensuring that you put a good amount of gain when you are recording, depending on what you are recording, is important, as this gain helps us to determine the signal to noise ratio, which is the difference between the signal which is wanted and the noise in a signal and noise in our sound signal. So we should ensure that we put a reasonable amount of gain on what we are recording. If we don't, we are going to end up with a signal which is going to be bad or low quality. So on our audio interface, what we have here is the input, the pads, the phantom power, and the phase and the link. Okay, so I'm going to talk much on starting with the phantom power. The phantom helps us to activate the microphones which have an active circuit which require a 48 volts phantom power to be active to start recording. So pressing the phantom power for each signal channel which we have chosen here activates the microphone. This is a low cut filter. It cuts out the low frequencies and lets the high frequencies pass if you press on it for each channel. If it's armed, it means it's filtering. And the other important part is the phase, which is used to switch the signal's polarity. Okay, and looking here again, this audio interface has this. Here we can see, we can read the inputs channels, and here it shows the sample rate which we are using. As I said, here it's supposed to be 48, and even here it's supposed to be 48 when you're recording. So this here helps us to control the level at which the monitor speakers are producing sound, so that we can control the loudness. If it's too loud for us when monitoring, we reduce. And of course, it's required mostly that we put at a level where the sound which is being produced or performed there is the same as in here in the monitoring in our studio. And we can see here is our on and off button. If you are done with what you are doing, you switch it off. If you are beginning to record, you switch it on. This button here powers up this audio interface. And just looking behind here, we can see the channel inputs I was talking about. They are wonderfully and nicely labeled for us to interact with them easily. We can see it's up to 8 channels, and the other audio interface down there also has 8 channels. Yes. So if you feel like this one is not the one you want to use, this Apollo X8P, in our studios we also have this complete audio 2 interface, which also acts as the same as this one. It has this output knob which controls the levels to the monitor speakers, and of course most of the things I've talked about here. And it also has this combo connection, which is an XLR and also a TRS-TS cable input. Yes. So from there I can go on. So from the computer we have talked of the link between the two, and since we have talked of this link, let's talk of the link between the interface and the instruments. In our studio, if at all you want to track an instrument, let's say a guitar, you want to track a bass guitar, and you feel like there is some noise, we have this which is called a DI box, a direct injection box, which is used to increase a low level signal into a higher level signal, or it is used to reduce the high impedance signal into a low impedance signal, which means that our signal has less resistance, it has less noise in it. So here we can see that a DI box has also parameters which we need to consider talking about. First of all, we are going to talk of this ground lift, which is a button here. So the ground lift is used to lift the ground in a signal which might not have a ground, and when you press this button, it means the ground is going to be lifted in that signal, and hence this DI box is going to reduce noise in that signal, if at all that noise is coming because of the ground. And here we have the pad. A pad, just like on the interface, is used to reduce a hot signal to a manageable amplitude level which can be managed, which is required. And here we can see that it has the link output and the input. So on the input here, let's say, as I was saying, in a case we have a bass guitar, we can put our instrument cable here, which will go to the cable guitar, which will go to the bass guitar. And since the signal which is coming here is not balanced, and it is of instrument level, this is going to output a balanced signal, and what we can see there is an XLR male output. And how it makes it balanced is that we have talked of the ground. So when the signal comes in unbalanced, it will leave this DI box to a level where we can say this is good. and it's not going to have any phase in it. No, it's not going to lose strength, and this is very important when you are running long cables. So between the instruments and the long cables, you can put this so that it converts that unbalanced signal into a balanced signal. Okay. Having said that, I think we are done. Another thing I should mention is what we have here is an active DI box. And since it is an active DI box, it boosts the level of our signal. As I said, it boosts the level of our signal. It has a transformer which boosts the level of our signal. And from there, next, I'm going to go to the headphone amplifier. So what an headphone amplifier does is it gets the signal and it boosts it to the level where we can hear it through headphones. It creates more outputs for our performance, and this helps us to talk to them, which is known as talkback. It facilitates talkback in a way because if we have this headphone amplifier, we can place our input here, which is, let me show you the cable which is used. This is our TRS cable, which we place on the headphone amplifier, and this we connect on the snake cable. I'm going to show you the snake cable we use and where we can place this. And having done that, we have these which are 4 outputs, so we can connect 4 headsets or headphones. Let me show you the headphones, and having these headphones connected to this headset adapter or headphone adapter, we can connect on the output there, and our performers can easily interact with us if this is connected on the snake cable. And we can see here on what we connect on the snake cable is the female XLR tip or pin or plug. Yeah, it's a XLR plug. Having said that, I think here we have these knobs which controls the levels of the signal which is head, because you might find that it's too strong, you can reduce it. If it's too weak, you can increase it so that you monitor the required sound. Now on, we are going to talk about microphones, because a studio is supposed to have microphones for you to record instruments and voices. Microphone is something which, or an equipment which transforms sound waves or air pressure waves into electric signals or electromagnetic signals, which can be recorded and stored and reproduced, of course. So a microphone reproduces sound. So I'm going to start first with one kind of a microphone, which is known as a dynamic microphone. And in my hands, I have a Shure SM58 dynamic microphone. As we can see, this is a dynamic microphone. This is the shape of an ordinary dynamic microphone. And we can see here a dynamic microphone is shaped in this way because it's a front addressor microphone. It has a cardioid pickup pattern. Here is where sound is picked up from. So inside this head, we can, if we open, we'll find a coil, or that coil we are also going to find a magnet, and inside there we're also going to see a diaphragm. And the link is that the diaphragm is linked to the coil, and is surrounded by a magnet. So when you speak, or when someone sings, or an instrument is played, the diaphragm is going to vibrate, And since it's connected to the moving coil, the coil is also going to vibrate, and it's going to produce an electromagnetic frequency sphere, which is going then to produce a current at the terminals of the moving coil. And that current produced is direct proportional to the sound, which is of course picked up from here. And once that is done, that means the sound has been converted into an electric signal by a dynamic microphone. And as I've said, the pickup pattern of a dynamic microphone is a cardioid, and these microphones don't have the proximity effect, which is the effect of boosting low-end frequencies, or and when we compared to other microphone, of course, like the condenser microphone, which I'm moving to. So this microphone is good for instruments and voices. They pick sound as it is without boosting the low frequencies. Okay, moving on to the condenser microphone. With me here, I have two condenser microphones, and firstly, I'm going to talk of this one. With me here, I have this Mojave condenser large diaphragm microphone. This is a condenser large diaphragm microphone, and it's different from a dynamic microphone in the sense that it doesn't have a moving coil. Instead, it has capacitors which pick up sound, and those capacitors, they are different from from the setup here. The capacitors in here are supposed to be activated by a certain amount of voltage, which is called the phantom power. As I explained earlier, the phantom power activates the circuit in this microphone for it to start vibrating according to the pressure or the sound pressure which is produced, the waves which are hitting it. So it also, when it vibrates, the sound is picked up, converted into electric signals, and here on the outputs, even this one has the same output, and XLR male output. And here we connect our female XLR, making sure that it's tightly fastened in the socket there, so that there are no noise which is created by loose connections. And from there we can see another type of a condenser microphone, which is this one. This one is an AKG C451B condenser microphone, which is a small diaphragm, in the sense that we can see this one is big here because it has a large diaphragm which vibrates. This one has a small diaphragm with it. And one difference we can find is that this one only has a pickup pattern which is similar to the dynamic microphone, which is a cardioid pickup pattern. It picks sound from this side. And again, we can find other things on a condenser microphone, which of course here we have the pad, which is used to reduce the level of our signal. So if we change, there is 10, -10, -20. So if we put at -10, it's reducing by -10. At -20, it's reducing by -20. We also have the filter here, and we can see that we have the low cut filter. Yes, at 75 Hz, it means we are cutting, or 75 Hz, and 150 Hz, it means we are cutting the 150 Hz. And this is the similarity between the two microphones. Even this one has those features here. And this one also has the ability of changing polar patterns, unlike this one, in the sense that this one is only a cardioid pickup pattern, but this one has a lot of pickup patterns. Let me show you here. We have the we have the omnidirection pickup pattern here, which is like a circle, labeled like a circle, and we have the heart shapes here, which is the cardioid, and we have the figure 8. So the omnidirection means the sound is going to be picked in all directions of the mic. But for the cardioid pickup pattern, it means only one side of the mic. The front side of the mic in this case is going to be picking sound. And if we put it at figure 8 or bidirection, it means it's going to be picking from this side and this side, excluding this side, since it's not omnidirection, of course. And that is one difference between the condenser microphones and the dynamic microphone. And of course, between the same two microphones, we can see that there's a difference. This is small, this is large. This one is usually used for voices, and it has a proximity effect. It has the characteristic of boosting low end frequencies. You'll find that they are sounding more exaggerated. So it should be considered when recording. You take it into consideration that you place the sound source at the right distance from the microphone, of course, depending on what you want to record. That's all about the mic. Forward, we can talk about the monitor speakers which we have. Although I might mention that let's not consider the placement of these speakers. I'm going to demonstrate later how we can set up our speakers. So in our case, we have these two monitor speakers, the left and the right. So speakers, they recreate, they in short, they make sound from an electric signal. So an electric signal is transformed into sound. As at first sound was converted into an electric signal, and from there we can hear sound and monitor how it feels from the speakers. The speakers, what we have here are active speakers, and of course they are powered by themselves, and they have amplifiers in them. So the speakers are connected to the interface here, and we can control the level of the speakers through our button here. And something else I should say about the speakers is, okay, so this audio interface has the analog to digital audio converter and the digital to analog audio converter. So the analog to digital audio converter converts the analog signal into a digital signal through a process called sampling. As I mentioned earlier, I talked of the sample rate, which is the rate at which a number of samples are taken, and sound is supposed to be sampled twice its highest frequency in that case. So, and digital to analog converter converts the digital signal into an analog signal, which can be converted by the speakers into sound.